Let us discuss numpy in detail. Numpy stands for numerical Python and it includes various mathematical and logical operations. So, in case if I want to do any arithmetic operations, I can use numpy. With numpy we also work with arrays, and in arrays we have homogeneous collection of data. Homogeneous as in all the elements are of to be same type, should be of the same data type. I cannot have a number and a boolean. No, whatever it is, it has to be of one data type. It can be either numbers, it can be characters, booleans, but whatever it is, it has to be only one data type. Numpy arrays are also called as n-dimensional arrays, since I can include n-dimensional, many multi-dimensional arrays also here. If I have only one dimensional array, it looks to me very similar to a list, but there are some notable differences between numpy arrays and lists. Numpy arrays, one major difference is one numpy arrays will include data of a single type, but in lists I can include data of multiple data types. The next point is the data in arrays cannot be directly initialized. They can be, everything has to be operated through numpy package. In lists, it can be directly initialized. Direct numerical operations can be done. So, for example, dividing the whole array by 3 divides every element by 3. Numerical operations are not possible with lists. That is, I cannot say list by 3 and all the elements are going to be divided by 3. No. And numpy arrays are mostly used for arithmetic operations, but lists are used for data management. So whenever I want to use some arithmetic operations, I will go for numpy arrays. I will not go with lists. Arrays take less memory space, and lists comparatively take more memory space. Now let us see creating a numpy array and creating a list. So import numpy, capital A is equal to numpy dot array of, and here I am initializing it with some numbers. To create a list, I only have to say A is equal to brackets. So uh, the da- the major notable noticeable differences are: here it has to be of the same type. In numpy array, here it can be of different type. These work with every time with numpy dot array. Okay, they can be operated with numpy dot array package every time. They are mostly used for arithmetic operations. So for example, if I say a by 3, it will divide each element by 3. Direct numerical operations are not possible in the case of lists. They take less memory space, they take more memory space. uh, so let us see, what if I want to initialize numpy arrays. So creating a numpy array, I can say numpy dot array of, and I can give in some elements. What if I want to create a two dimensional zero array? That is, every entry in the array has to be zero, or every entry in the matrix, I may call it matrix, has to be zero. So if I have a two dimensional zero array, let's see, 4 cross 3, 4 rows and 3 columns. I use zeros function in numpy package. Numpy dot zeros of 4 comma 3, 4 rows, 3 columns. Creating an array with 5 random values, I say numpy dot random of 5, that I'm looking for 5 random values. Creating a two dimensional constant value array. Constant value means I'm specifying the value that I want. 3 cross 4, 3 rows, 4 columns. So I say numpy dot full. See, in this statement, I want 4 comma 3 with all values 0. Here I want 3 rows, 4 columns, and the value has to be 6. Uh, Creating a sequential array from 0 to 30 with gaps of 5. So here I will say arrange. Arrange is the function that I use for creating an array with gaps of 5. So 0, 1, 2, 3, 4. Then the next row will have 5 5, 6, 7, 8, 9, and and so on. So numpy dot arrange 0 comma 30, and the gap of 5 has to be introduced. So arithmetic operations can be applied. So if I say ARR is equal to ARR plus 5, each and every element gets added with 5, and then the result is again stored back to ARR. I can divide each element by 5. I can square each element. So if there is 2, 4, 6, it becomes 2 square, 4 square, 6 square. If I want to access the second element, I say ARR of 1 in square brackets to access the second element, because the subscript starts from 0. To multiply two arrays, I say ARR into BRR, where these two are numpy arrays.